Hello everyone and welcome to Ignite Spring 2021. My name is Ali Zaman and this is the hybrid connectivity session. In this session, Ajit Bolhar and I will be talking about different options to connect to Azure securely. I will first talk about VPN gateways and then hand it over to Ajit to talk about ExpressRoute, Azure Route Service, and Azure Bastion. So let's get started. Azure VPN Gateways provide secure cross-premises connectivity to Azure virtual networks over the public internet. This can be from a customer network or a customer device. We support two different connectivity models, site-to-site and point-to-site. Site-to-site VPN provides connectivity from a customer network to Azure virtual networks. In site-to-site, you need a device on the customer premises that has a public IP address or is behind a NAT. We support BGP for dynamic routes as well as allow custom IPsec policies. Point-to-site VPN can be used to provide connectivity to remote users that are working from different locations. In point-to-site, you don't need a device or a dedicated device on the customer premises. All you need is the user device that has access to the internet. We support many different protocols and authentication methods for point-to-site. For example, we support IPv2, OpenVPN, and SSTPS protocols, whereas for authentication, we support Azure Active Directory, CERT-based authentication, and Radius. Over the years, we have added many features to our VPN gateways. But for today, I will just focus on the features that are upcoming and that we are announcing at Ignite. There are a lot of organizations that have a heterogeneous environment where Windows, Mac, and Linux clients need access to the same resources in Azure. These platforms have different capabilities and different VPN clients. For example, we only support Azure Active Directory authentication for Windows, whereas for Mac and Linux, we support certificate-based authentication and Radius. To overcome these challenges, you can now define multiple authentication types on a single VPN gateway. This will help when you have different client operating systems and need to connect and access the same resource. For example, you can leverage AD authentication for your Windows clients and use CERT-based authentication for your Linux and Mac clients. Please note that this support is only available for the OpenVPN protocol. We have also added NAT support for site-to-site VPN. This would be useful to provide business-to-business connectivity where both the businesses are using the same private address space. This can also be used in case where branches have overlapping address space and you need to masquerade the IP ranges. We support two different NAT policies. First is one-to-one static NAT. This provides bidirectional connectivity. The second one is many-to-one dynamic NAT. This only supports unidirectional connectivity and can be used to masquerade an address range. We have also made a lot of enhancements to monitoring and diagnostics for VPN Gateway. We have launched a new dashboard that shows a lot of the BGP related metrics. For example, you can see the session state of the BGP. You can see the routes that are being learned by the gateway and the routes that it's advertising to other networks over BGP. You can now reset a single connection in a VPN gateway. This would be useful when the gateway has many connections to different destinations and you just need to reset one single connection without disrupting the other connections. We've had packet capture support using PowerShell for a while now. We've added this capability into Portal as well. You can use 5-tuple filters for your packet captures. For example, you can specify a filter on the source and the destination IP range or IP address, the port, and so on. The Azure VPN client for Windows has been a huge success with our customers because of its support for Azure Active Directory authentication. So we are working on a client for macOS and we will be announcing that soon and it will be available shortly. Let me share a short demo with you about the client.
This is a new Azure VPN client for macOS that is coming soon. The main screen shows the existing profiles, and if you highlight a profile, you see the connection properties, such as the name of the profile, the VPN server that it's connecting to, and the type of authentication. Once you have downloaded the profile from the Azure portal, you can easily import it into the client by using the import button and browsing to the location of the file. Once the file has been imported, it shows up in the main window. You can also export an existing profile to a file that can be used later on. For this demo, I will start a Wireshark capture so we can observe the traffic. I will also ping a VM in the Azure VNet. As you can see, it's not responding at the moment. Let's connect the VPN. Select your credentials. Let's look at Wireshark. We see OpenVPN packets going through the adapter. Let's try and ping the VM, and we see replies from the VM.
Thank you. And with that, I will hand it over to Ajit to talk about ExpressRoute, Azure Route Service, and Azure Bastion. Thank you.
Thanks for the handoff, Ali. Hello, everyone. My name is Ajit. I'm one of the program managers supporting hybrid networking. Today, I will be presenting on ExpressRoute, Azure Route Server, and Azure Bastion. Let's get started. So what is ExpressRoute? ExpressRoute is a routing service which allows Microsoft customer establish a direct network connectivity to Microsoft Cloud over a private network. In the diagram, you can see that the customer network is connected to a partner edge, which in turn is connected to Microsoft services via Microsoft Edge. ExpressRoute provides two types of peering services. Number one, Microsoft peering. Customer can use Microsoft peering to connect to services like Office 365, Dynamics 365, or an Azure public service which are accessible over the internet. Number two, Azure private peering. So what is Azure private peering? Azure private peering allows customer to connect to their virtual networks via private link. In this case, the private link is the ExpressRoute circuit. In short, what it is allowing to do is to allow the customer to have an extension of their network into Microsoft network. So let's look at few of the connectivity models that are currently available for customer to choose from. Number one, cloud colocation. In this connectivity model, the customer is already co-located in the same location where the ExpressRoute provider is located. All customer does is that they order an Ethernet connection from the cloud exchange provider and connect to the Microsoft services. Point-to-point Ethernet connections. This is slightly a little bit different. In this scenario, the customer orders a layer 2 or an Ethernet connection from a service provider and connect their on-premise or a data center to the Microsoft Cloud. Any-to-any IP VPN connection. This service allows a customer to extend their WAN services into Microsoft Cloud. ExpressRoute partners hands off a layer 3 service to the end customer, and then in turn, customer go ahead and configure the routing services needed to connect to the Microsoft Cloud. From a customer perspective, this is no different than having another branch connectivity that they have currently in place. So the fourth option is ExpressRoute Direct. In ExpressRoute Direct, the customer directly connects to Microsoft devices to consume Microsoft Cloud services. There is no ExpressRoute partner in the middle. All the connectivity between Microsoft and the customer is dedicated and direct. In this slide, I briefly wanted to talk about how exactly the cross-connect happens between the customer routers and the ExpressRoute provider routers. This is just a very high-level diagram. In this, what you can see is that in the middle, we have a ExpressRoute provider routers, and on the right-hand side, we have a Microsoft cage where Microsoft routers are deployed. Customer is already co-located in the same location where the ExpressRoute provider is located. Customer orders a layer 2 connections, in this case, which is an Ethernet connection, and in turn go ahead and connect the Ethernet connection from their routers to the ExpressRoute provider routers. This is a patch panel to patch panel connections. Because the connection between the ExpressRoute provider and Microsoft routers is already placed, this leads to a faster turnaround for the provisioning of an ExpressRoute circuit. In this slide, you can see in the ExpressRoute Direct model, the customer routers are directly connected to the Microsoft routers. Customer is already co-located in the same location where the Microsoft routers are located. Customer orders the layer 2 connections, in this case an Ethernet connections, from the facility providers, which in turn provide the connectivity from the customer routers to the Microsoft routers. This is also a patch to patch panel connection, and there is no customer provider in between. Let me go over briefly the difference between the ExpressRoute service provider and the direct model, and in what situation you should use which service. ExpressRoute Direct is useful for customers who wants a dedicated and a direct capacity. This is very much needed in regulated and in the situation where there is a massive data ingestion is required. For example, you required 100 gigs of connections or a 10 gig of connection with the full management of layers, then ExpressRoute Direct is the way to go. You want different business units within your organization to have a different circuit SKU. Instead of deploying or buying multiple circuits from the ExpressRoute providers, now you can buy an ExpressRoute Direct circuit and go ahead and configure different ExpressRoute circuits on top of it. So on the physical layer, you only have one port pair available, but on top of it, logically, you divide the connections into several smaller speed SKUs. For example, a 10 gig circuit can be divided into two 5 gigs connection, or a 100 gig connection can be divided into a 5 gig or a 10 gig connections, supporting multiple different types of connections. In the service provider model, it is very much useful for a single tenant. It is very much optimized for a single tenant. In this model, customer can order from a SKU from a 50 megabits per second all the way up till a 10 gigs per second. Also helps with faster onboarding because the infrastructure between the Microsoft network and the ExpressRoute partner is already in place. Let's look at the various design patterns that customers have deployed on Azure Cloud. The first one flat VNet. In this, the customer deploys a single VNet and connect it to the ExpressRoute circuit. It's a very common scenarios and a design pattern that is deployed by Microsoft customers. But it comes with certain limitations. Customer needs to be aware of subscription level resource limits and how many resources they can deploy within a subscription. Also, it provides fewer choices when it comes to security and compliance setup. Let's look at the second design pattern. In this design pattern, customer has deployed multiple VNets on Azure Cloud, and these VNets are in turn connected to an ExpressRoute circuit. Think of a scenario where customer has multiple business units and they all need their own VNet to keep their workload separate from each other. And this design pattern solves this problem. It also provides each business unit to go ahead and implement their own security and compliance boundary. The limitation of this design pattern is though that you can only connect so many VNets to an ExpressRoute circuit. Also, the cross VNet traffic can be limited by the ExpressRoute gateway. Let's look at hub and spoke model. In this model, customer deploys a hub which hosts a common services. For example, in this scenario, the ExpressRoute gateway, you can have an NVA, which are hosted in the same hub, which in turns are connected to the spoke VNets. Spoke VNets have connectivity to the hub VNet over VNet peering. You can consolidate all your security policies to an hub VNet, but it adds a management overhead, and also because all the traffic is going via the hub VNet, it also introduced bottlenecks at the hub from a traffic perspective. In this slide, we will be talking about how customers should deploy a strategy for their disaster recovery. As you can see, customer has deployed a service in region 1 and in region 2. This region can be an AZ enabled region or could be a non-AZ region. The key point that I wanted to make over here is that for a disaster recovery scenarios, customers should consider to deploy multiple ExpressRoute circuit. And in the event of one of the regions going offline, customer can then choose to route their on-premise traffic via their own WAN network or over a Microsoft network. So in this scenario, when the region 1 goes offline, a customer can use different BGP policies to route the traffic via the blue path to connect to the region 2, or they can route via the gray path to connect to the region 2. The key thing over here is to keep the routing symmetric. Customer can use different types of BGP attributes like AS path prepending, connection weight, and local pref to achieve this deployment. In this slide, I would like to talk about how customer can use IPsec over ExpressRoute. In the diagram, you can see that the customer already has an ExpressRoute circuit, which is connecting customer on-premise network to an Azure VNet. On top of that, customer deploys an IPsec tunnel. You have an on-premise VPN and you have an Azure VPN gateway, which are connected by site-to-site tunnel. This provides an end-to-end encryption for a customer between on-premise and the Azure deployment. Key things to remember over here is that the ExpressRoute service here act as an underlay service and the VPN service is an overlay service. And customer can deploy this setup over Microsoft peering or over an Azure private peering. One of the key things the customer should keep in mind is that they cannot advertise the on-premise route over an IPsec tunnel as well as over an ExpressRoute. In the event that happens, the Azure VNet will learn the routes from Azure VPN gateway as well as from an ER gateway. And that will become a coexisting scenario. In that case, the ExpressRoute path will always be preferred over the VPN path. Let's look at new feature announcements for ExpressRoute service. We are excited to announce support for IPv6 private peering for ExpressRoute service. As you can see in the diagram, the customer has deployed a dual stack deployment. They have an IPv6 address and they have an IPv4 address under the application subnet, which in turn is connected via an ExpressRoute circuit to the on-premise network. Customer can deploy their own IPv6 address space in the virtual networks, which ExpressRoute as a service will advertise to on-premise network over IPv6 peering. Currently, we only support this feature over AZ-enabled gateways. Support for the non-AZ regions will be coming soon. We are also releasing new supportability improvements for the ExpressRoute service as a whole. We have heard from a lot of customers that they should be able to diagnose the problem themselves when there is an issue happening with their service. Now customer can go under the ExpressRoute blade and they can run certain diagnostic settings based on the problem that they are facing. In this screenshot, customer is having an issue with ExpressRoute circuit. We run certain diagnostics in the background and we are able to see that there is an incomplete ARP entry which is causing problems for the circuits to come up. We also recommend certain steps that customer can take in order to resolve these problems. So this is becoming a much more like a self-service model where customer can come, diagnose the problem, and take certain actions by themselves to resolve these problems. Let's look at the few more features that we have released. For example, now customer can advertise more than 1,000 prefixes from Azure to on-premise. Previously, this limit was set to 200 prefixes, which is now increased. We have also released new gateway health metrics that customer can consume to see the health of an ExpressRoute gateway. These includes CPU utilization of a gateway, packets per second, number of route advertised and received, the frequency of route changes, and the number of VMs in a VNet. The CPU and the packets per second metrics shows the performance and the throughput utilization of an ExpressRoute gateway. Number of route advertised and received, and the number of VMs in a VNet are the indicator of the scalability of an ExpressRoute gateway. I really wanted to talk about frequency of route changes metrics. This metric shows how many times a BGP update or a route update over BGP has been received by an ExpressRoute gateway. This is a very good indicator of whether there is a route flap happening within a network. Depending upon how frequent you have a route flap, you may see a route churn, which in turn can cause performance and latency issues for the customer application. In coming months, we'll also be releasing the support for MACsec SCI and the new cipher support for the MACsec feature. With MACsec SCI support, customer can now enable and disable the SCI configuration for their MACsec deployments. Let's look at the demo for the ExpressRoute health metrics that we have released recently. In this demo, we will be showcasing the various metrics available to monitor the health of an ExpressRoute gateway. These metrics are available on Azure portal under Monitor Blade. Let's get started by selecting a scope for an ExpressRoute gateway. Under the resource type, please make sure you have selected virtual network gateways before selecting Apply. Now we are under the Health Metrics workspace. Under the metric menu, you can select from the various health metrics available for the gateway. For example, count of routes learned from peer shows the number of routes learned by an ExpressRoute gateway from on-premise. In this case, the number is 4,200. You can select CPU utilization to monitor the performance of an ExpressRoute gateway. Packets per second shows the throughput of an ExpressRoute gateway at any given time frame. You can also configure a custom threshold-based alert under the new Alert Rule tab. In the event the alerts are fired, you can take a proactive action to resolve the issue. For example, you can upgrade your ExpressRoute gateway from standard to an high perf or to an ultra perf gateway as needed. This concludes our demo. Thank you. Azure Route Service. Azure Route Server is a new service which is currently available under public preview. So let's look at this service. Azure Route Server provides a BGP endpoint that a network, a virtual appliance can connect to for a dynamic route exchange between the NVA and the Azure Virtual Network. What exactly I mean by that? In this diagram, you can see the customer has an SD-WAN appliance as well as a firewall network virtual appliance. These both appliances are in turn paired with Azure Route servers over BGP. Once the peering is finished, now the virtual networks in the bottom, which is the app subnet, can learn on-premise routers from the Azure Route service as well as a default route from the firewall NVA. No need to configure user-defined routes anymore. It simplifies the NVA deployment on the Azure. The service also supports any kind of an NVA. It's agnostic to any network topologies. For example, you can deploy in a single VNet, hub and spoke, or in a full mesh topologies. Azure Route Server also integrates with ExpressRoute and the VPN Gateway. Customer do need to keep in mind is that for an NVA to be integrated with an Azure Route service, it needs to support BGP, which is a standard routing protocol. And also, it needs to support a multi-hop BGP configuration. Azure Route Server already has high availability built in. As you can see in the diagram, we have two NVAs which have BGP peering with the Azure Route servers. There are two instances of VMs that are deployed under Azure Route servers, which provides high availability for the service. Customer can also deploy two or more NVAs for redundancies and set up BGP mesh between the network virtual appliance and the route servers. Services provided by Azure Route Service are control plane only. The data traffic flows directly between the NVA and the VM. Customer can deploy the service in an active-active manner or an active-passive design using AS path prepending. Let's look at the SD-WAN use case. In this scenario, a customer has deployed ExpressRoute Gateway and the SD-WAN virtual appliance in a hub. Azure Route Service now peers with ExpressRoute Gateway and the SD-WAN appliance over BGP and learn the on-premises route from both the SD-WAN appliance as well as the ER gateway. In the event the ER gateway goes down, the traffic seamlessly gets transferred over to an SD-WAN path. All the routes updates are done by the Azure Route Service to the virtual network dynamically. Let's look into ExpressRoute and VPN use case. In this scenario, in a hub VNet, customer has deployed at the VPN gateway as well as the ExpressRoute gateway. The Azure Route Service automatically detects the VPN gateway as well as the ER gateway and automatically peers with them. There is no manual intervention is required. The routes gets exchanged once the peering is set up. In this scenario, you can see that the VPN gateway allows connectivity to on-premise 1 and the ER gateway allows connectivity to on-premise 2. Once the BGP session is established between the Azure Route Service and the routes are exchanged, now customer can also talk between on-premise 1 and on-premise 2. Just a brief overview about Azure Bastion as a service. So what is Azure Bastion? Azure Bastion is a PaaS service which allows customer to connect to their virtual networks over RDP and SSH connection without the need of a public IP address. In the diagram, you can see that the customer logins to the Azure portal and then launch the Azure Bastion service to connect to the Azure VM over RDP and SSH. This provides a secure and a seamless way to connect to the Azure VM over public networks. Let's discuss the new feature announcements for Azure Bastion. Bastion now supports Azure Key Vault integration. What does that mean? Customer can use Azure Key Vault to store their SSH private keys. So now they have a single location where they can safely store all their SSH keys. At the time of login, customer can reference these keys via an Azure Key Vault and pass the credentials safely and securely to the VM. User can now also manage their AKS nodes over RDP and SSH using Azure Bastion. This feature is now currently available for users to use. We're also publicly previewing the feature for resource health check. Customer can now see the health of the Azure Bastion service under the resource health tab. They can see if the service is running healthy or if the service is unavailable or in a degraded state in the event they see connectivity issues to the VM via an Azure Bastion. In the coming months, we will be releasing Bastion Health Matrix and Bastion Scalable Gateways. Bastion Scalable Gateway will allow customers to have as many as 500 concurrent connections, also provides an ability to decrease the size of the gateway as per their usage. In this screen, I wanted to highlight the Azure Bastion integration with Azure Key Vault. As you can see, when the user tries to connect to a VM via an Azure Bastion, now we give them the option to use Azure Key Vault for their SSH private keys. Once the Azure Key Vault subscription, the name, as well as the secret is provided, user can go ahead and then select from the SSH keys that are currently stored on the Key Vault and click Connect. The SSH private key then will be seamlessly transferred to the VM for connectivity. With that, this concludes our presentation, and thank you.